Hey everyone, and welcome back. In this video series, we're going to take a look at the power series of amplifier products that Rockford Fosgate manufactures and take a look at what they're all about. For over 30 years, Rockford has been known for big power and big bass, and we've been an industry leader in technology and amplifier design. We've been awarded numerous technology patents for our circuitry design, a lot of which has been incorporated into our power series of amplifiers. Early on in this series, we talked a bit about those circuit designs, but let's review what they are and what helps set the power series apart from other manufacturers. So first up is the punch EQ circuit. This is one of the original circuits designed by Jim Fosgate himself in the early 70s and has been refined over the years to be what it is today. The current version of the circuit provides a bass boost of up to 18 dB at 45 Hz on any of our monoblock version amplifiers or multi-channel full range amps when set to low pass mode on the crossover. It can also boost the high frequencies on the multi-channel amps when in high pass mode by up to 12 dB and is centered at 12 kHz or 12,000 Hz. When in all pass mode, it will affect both frequency bands at the same time. Next is DTM, or Dynamic Thermal Management. This circuit monitors the temperature distribution throughout the amplifier's output section and heatsink and is able to shift some of the load to the power supply to help equalize the heat output and maximize the use of the heatsink instead of allowing the amp to heat up in just one spot. Also used is MESA, or Maximum Efficiency Heatsink Application. Used in conjunction with the DTM, MESA is the process by which we mount the MOSFETs to the heatsink. Using a ceramic-coated aluminum plate between the MOSFET and heatsink allows for greater surface area contact and increased heat distribution. NOMAD, or Non-Multiplying Advanced Decision, is the analog computer that monitors and calculates the maximum safe current allowable based on each channel's load. This increases the precision of the protection circuit and allows it to offer protection against a multitude of possible problems, such as short circuits, over and under voltage conditions, and thermal issues. Finally is our constant power circuit. First introduced in our 2010 model power series amplifiers, this circuit monitors the dynamic relationship between the musical frequencies being sent to a speaker and the changing impedance of the speaker's voice coil at those frequencies. This allows the amplifier to adjust its output power to maintain power levels to the speaker and gives up to a 25% increase in overall power from the amplifier. Now, cool circuitry aside, another element of the power series amplifiers is their circuit topology or circuit design that is used. Now, two of the classes that Rockford uses are Class BD and Class AD. But what are they really, and what's the difference between them? If you've been around car audio, even for a short time, I'm sure you've probably heard terms like Class AB and Class D. The class of an amplifier describes the circuit design and function of that particular amplifier in relation to its intended purpose. Commonly, AB amplifiers are for full range applications, and Class D are for subwoofers. Now, Rockford has improved on these designs in an effort to increase amplifier efficiency and power output while reducing the physical size of the amplifier itself. Now, Class D amplifiers, or sometimes called switching amplifiers, switch on and off at a very high predetermined frequency rate. Now, this helps maintain signal resolution or sound quality, but can have an effect on the efficiency of the amplifier. Now, our Class AD full range amplifiers use a dynamic switching frequency control, which can increase the frequency at low volumes and provides for better signal resolution, and then lower frequencies at high output levels, where the SPL output will mask any lower signal resolution. Our Class BD amps, since they're used only for lower frequencies, use a lower switching frequencies to maximize on the power efficiency, and any signal resolution loss is masked by the SPL output of the subwoofer. Class BD amps also use approximately twice as many components when compared to the AD models, which helps spread out the electrical load over a much larger area and allow for the amplifiers to produce higher output levels without overloading those components. Now this is what helps to contribute to the kind of power that you see from our class BDCP models, from the T500 all the way up to our big T2500 model blocks. With the addition of the CP circuitry, we've seen power output tests on our T2500 exceed 3,000 watts RMS at a 1 ohm load, which is pretty impressive. Also, our AD models are nothing really to sneeze at either. Any system that you need a high power capability in a full range amplifier, we have our T800 and T1004 AD models, which bring it and then some. With ratings of 150 and 250 watt RMS respectively per channel at a 4 ohm load, the AD series amps truly can deliver the power, but they retain a nice high fidelity output. Now all of this, coupled with high mass heat sinks, variable crossovers, and balanced differential inputs, is really what sets the power series of amplifiers apart from all the competition. So hopefully this gives you some insight to the power amps and the technology behind them, and I'll see you again in the next video.